Got the hang of it? Okay, let's go to our molecular covalent compounds. They're going to be all non-metals, and so we're going to be sticking with these things over in this triangle here. There's about 10 elements plus our problem child hydrogen. We are only going to worry about naming the binary ones. Now, first of all, remember I told you organic compounds have a different set of naming rules. So if you see lots of carbon in something, that's not something we're going to try and name. I'll throw a few that have carbon in them that are not organic. You're just going to have to trust me that if you see a carbon, you're going to use these rules. I'm not going to give you organic ones to try and throw you off. Okay, so these are all nonmetals. We are going to work on binary compounds, which have two elements. And the nice thing is that the basic structure is very similar to naming the inorganic or the ionic compounds. We're going to have two names. The first one's going to be an element. The second one's going to end in I. So we're going to name them in the order of the formula. And first is element name. Second ends in I. But we can't just leave it at that, because remember we briefly talked about the law of multiple proportions, which said I can take two elements and combine them in lots of different ways. So if these are my only rules, then all of these compounds have the same name. We have to have some way of distinguishing those compounds. Now, especially with nitrogen, a lot of them go by older names. So if you just Google what's the name of this compound, you're going to see things like nitrous oxide. And that really doesn't tell you how many there are of each of them. So we're not going to use the things that say like nitrous oxide. We're going to use prefixes again. So you only use prefixes with nonmetals. With these compounds, and then over here, the only way we use the prefix was with the water, which is all nonmetals, okay? We never use prefixes with the ionic compounds. So we will use prefixes to say how many. So if I have N2O, then I would say dinitrogen. So here's the element name, and there's the prefix, dinitrogen monoxide. Now we have a couple of quirky rules. Two of them have to do with oxygen, or not with oxygen, with mono.
Both elements get the prefix.
Both elements get a prefix.
Yeah.
Okay. With this exception. So the first thing is that when we have mono and oxygen together, we don't put two O's. So it's not monooxide, it's just monoxide. Okay. You can already see that in that name. And then the second rule is that we don't use mono for the first element. So if I have this very familiar compound, I'm not going to say monocarbon. I'm just going to leave the mono off just for the first part. I always use mono for the second part if it's appropriate, but for the first part, I'm not going to use mono. I'm going to call it just carbon. And then what do I use as the prefix for the oxygen? Di. Okay. Second will always end in I. Okay. So here we would have not mononitrogen, but just nitrogen monoxide. We just did this one. This one will be dinitrogen tetraoxide, dinitrogen trioxide, dinitrogen pentaoxide. Okay. Ni3. Yeah, we can do that one. Mononitrogen or just nitrogen? Just nitrogen. And then tri, and here we do leave the double N. It is triiodide. I won't be picky about that. I'll mark it on your paper, but I won't take off points. If you call it triodide, I know what you mean. But technically, we need both eyes in. Okay. So let's try going in the other direction. Let's do this one and, oh no, wait. I'm gonna need to write the names up. Okay. Here are some formulas that we don't normally call by these names, but you could. So nitrogen trihydride. Dihydrogen monoxide. And then just to throw our carbon in there again, carbon tetrachloride. All right, so take a second, try and figure out the formulas for those. Going in this direction, I think, is the easiest that most people find pretty easy. All right, so what's the formula for this one? NH3. Anybody know the name of that one that we would call it other than this? So this is a compound that is on your sheet, and we haven't gotten to it yet, so the fact that you don't know it now is okay, but we'll memorize it soon. This is ammonia. Okay, so this is often found in like window cleaning products, and we use it all the time in chemistry. Okay, what's the formula for this one? H2O. And that, of course, is water. And then this one, CCl4. Okay. All right. Now I mentioned that we have different naming rules when we have different situations. One of those situations is when we have acids. And so this is where we're going to look at our polyatomic ion sheet again. And if you look on the right-hand side, a bunch of those are acids. Not all of them, but a bunch of those are acids. So what are some of the common endings for acids, aside from the word acid? IC and OUS. Okay, so there is a pattern from where it comes from in the name of the compound that was the ion. So once you know the ion name, you can get to the acid pretty easily. But we'll take a look at this. Okay, so acids, first of all, how do we know them when we see them? There are three kinds. I'm only going to talk about two of them today. Binary acids have two elements. So it's H and then some other element. Almost always this is a halogen, but we could have HCl or we could have H2S. sometimes H2SE, but pretty much it's the halogens. Remember, the halogens is that column right next to the noble gases. Okay. So when I only have two elements, then I start with the word hydro, and then first part of the element name, so chlor or sulfur, okay? So, and then we end in ic, and then we add the word acid. So for all acids, we're going to end with the word acid. Now, if I see HCl, I could also use those naming rules. I could just call it first element by its name, hydrogen, second element, monochloride. So hydrogen monochloride would also be appropriate. The distinction is usually if it is dissolved in water, then we use the acid name. If you call it by the acid name in any circumstance, that is fine with me. So the acid name often will have AQ after it. That's what means dissolved in water. So if you see that, that's when we have to use the acid name. Okay, so on the bottom of this sheet, if you look at HF, HCl, HBr, HI, and H2S, when it has a G next to it, that says it's in gaseous form. And so they're basically using these naming rules, but being loosey-goosey about leaving out mono all over the place. That's just kind of a traditional thing. People will do that. I'm not going to test you over naming the gaseous forms. I'm more interested in the right-hand side where it says AQ. So HF would be hydrofluoric acid, okay? The one thing to pay attention to is that when we use sulfur anywhere else, we just use sulf and then add an ending. But when it's an acid, we use the whole word. Okay, so it's not sulfic acid, it's sulfuric acid. Okay, we're going to see something similar with phosphorus. We don't generally have binary acids with phosphorus in it, but when we get the oxo acids here, we'll see that too. So oxo acids look kind of like the oxo anions, but they have an H out front. The number of hydrogens and the number of oxygens might be the same, they might be different. Okay. So notice in both cases there's a hydrogen out front. When there's a hydrogen out front, if it is not water, we generally think of that as being an acid. Okay. And we'll find out next semester water can act like an acid, but that's getting ahead of ourselves. So how does the naming work here? Very similar, but we don't use hydro. Okay, so if I have, you look at the top, for all of the bold ones that I told you to memorize, all the ones that end in 8, nitrate, phosphate, sulfate, what does the ending become for the acid? Ic. Okay, so anytime you have an 8, you're just going to turn it into ic. So if the anion ending is 8, we turn it into ic. If the anion ending is ite, turn it into us. And then we just tack acid on the end. So we know that ClO4 minus was perchlorate. So HClO4, hydrogen is positive, so it's going to cancel out this charge. We're going to have perchlor, but then we're going to change this to ic. So I'll write this to the side here because I know I'm getting behind my computer screen. So perchloric acid. Okay. So let's take a look at PO4 3 minus, PO3 3 minus, and SO4 2 minus. So what are the names of these ions? Phosphate. And then when I reduce it by one oxygen instead of phosphate, it is phosphite. And then this one we memorized as sulfate. All right, so find those on your sheet and then look to the acids that are on the right-hand side next to them. The first thing to notice is that when my charge on my ion goes up, 3, so does the number of hydrogens. Okay, so this is H3, H3, and H2. Okay, but am I going to call this phosphoric acid? What's the name there? Phosphoric acid. Okay, so we don't use the whole name. We don't call it phosphorussic acid. We call it phosphoric acid. It's a little bit weird. And then what about this one? H2SO4. Sulfuric. So in most cases, with all the halogens, we're just going to stick with change 8 to 8. Look about the middle of the page. You should see an ion that looks like this. And then underneath it, it has its structural formula. What is the name of this ion? Acetate. This ends in 8. The acid that goes along with this, we change 8 to ic, and it becomes acetic acid. So C2H3O2H. See there? This is acetic. Okay. So phosphorus and sulfur are exceptions to just changing the ending. All right. I will see you all on Wednesday. And we can practice some names at the beginning of class if you want.